Thank you for joining me for this iSTEM Strategies project that focuses on the use of STEM notebooks as tools for iSTEM teaching and learning. First, let's quickly review the meaning of integrative STEM education, or iSTEM. As we have learned, iSTEM intentionally integrates the four STEM disciplines. Both content and process are purposefully integrated. iSTEM teaching requires the teacher or team of teachers to plan authentic, real-world integrated experiences that guide student-centered learning. This project suggests that STEM notebooks can be used as tools to help guide this teacher planning and student learning. STEM notebooks can guide teachers' purposeful planning of design and inquiry learning experiences. The use of STEM notebooks can help students organize their work and develop key habits of mind useful to scientists, technicians, engineers, and mathematicians. Our audience for this project is Corporate Landing Middle School in Virginia Beach. It is the pilot for a 3-year STEM curriculum project. 3 criteria are essential to this project. At least 2 of the 4 core disciplines must integrate their work. The technology teacher is supporting this work too. Curriculum must be problem-based, and teachers must include a design or engineering component to the problem. The overarching question for their work is, how does need drive design? The Virginia Beach STEM team wants the notebook to be process-based, not content-based. The design of the notebook will lend itself to guiding students to be critical thinkers, to problem solve, to learn through trial and error, to stretch their creative thinking skills, and to collaborate. The notebook will be a place to assess prior understanding and hinge new learning to past experiences. As a starting point, let's look at some research and evidence that supports the use of notebooks within science, math, and design classes. Notebooks have been used within K-12 science classrooms for years. A 2005 article in Science and Children identified these top 5 reasons for using notebooks. As a thinking tool, notebooks help students construct conceptual understandings. Notebooks help document students' thinking, which can guide teacher instruction. Students can practice several literacy skills within their notebook, such as procedural writing, narrative writing, descriptive writing, and persuasive writing. Notebooks can differentiate instruction for students. They have been found to be especially helpful for English language learners. Notebooks can be a common ground for teacher collaboration. Brian Campbell and Lori Fulton's book about science notebooks is a noted resource for science teachers. This book suggests that notebooks help students work through scientific processes in an authentic way. As a tool for learning, notebooks help students hone their scientific skills as observers, classifiers, and questioners. And notebooks help teachers focus on process skills. These reasons are echoed in questions, claims, and evidence. Science notebooks are used as a tool to help students refine their questions, gather evidence, look for patterns to support claims, and debate with others. Examples of student work can be found at the Science Notebooks website. These examples showcase creative and critical thinking, organizing data through graphs, and drawings that help students explain their conceptual understanding. It is more difficult to find information about the use of notebooks in math classes, and most call these math journals, not math notebooks. What's the difference? The difference seems to fall along the lines of whether the tool is used for reflection or used to develop certain habits of mind. A 2001 article co-authored by Marilyn Burns identified math journals as tools to help students stretch their thinking and make sense of problems that may leave them confused or frustrated. Math journals are the place for problem solving, student reflection through process prompts, encouraging students to talk through ideas and describe their thinking, and a springboard for rich class discussions. The journal is seen as a tool for both teaching and learning, a place for formative assessment where teachers evaluate their students' understanding, and a place for students to track their own reasoning. As this article presents math journals, they are tools for reflection. I looked at several examples of design journals. This one is used in Virginia Beach's middle school pre-IB program that uses problem-based curriculum. Projects begin with a problem statement. Students web their ideas in a concept map, and the work is guided using a design brief. The design cycle for this work begins with investigate, then plan, create, and evaluate. We can compare this work to these STEM notebooks. I contacted Liz Perry for examples of elementary STEM notebooks. Liz is the coordinator of K-20 STEM Partnership Development at NC State and a consultant for K-12 STEM Integrated Engineering Curriculum and Professional Development. She and Dr. Ernst have been working with several North Carolina elementary schools. We read about one of those schools in our 3rd set of readings. Liz is still working with Rachel Freeman Elementary and Brentwood Elementary, schools that fully integrate STEM within their curriculum. In a paper written for the 2008 ASEE National Conference, Liz and others discussed the important role of the STEM notebook. The students at Brentwood write in their notebooks daily. Students carry the notebooks to all classes. The notebook has become a tool for iSTEM learning and iSTEM teaching. Within the notebook, students were asked to describe, in words and pictures, what an engineer is and does. You can see some tools needed by engineers, and that engineers fix things, plan, and create models. The engineering design process used with these students is the design process supported by engineering as elementary. Students ask, imagine, plan, create, and improve. Testimony from one of the fourth grade teachers tells the tale of how STEM notebooks can be powerful tools for integrative teaching. She talks about how design projects allow her to extend lessons across the curriculum and intertwine the disciplines as she plans and teaches. This is testimony to purposeful and planned integrative STEM content. She continues by describing how her planning flows as she intertwines all subject areas to culminate with the final design project. She is engaged in iSTEM planning while her students are engaged in iSTEM learning. So how do we bring these successful elements together into a middle school STEM notebook? And what role will the notebook play in planning, teaching, and learning? These are the key pieces that I think should be in this middle school STEM notebook. The notebook will be process-based and problem-based. Problem-based is a requirement of Virginia Beach, but also a basic tenet of iSTEM education according to Dr. Mark Sanders. In a 2009 Technology Teacher article, Dr. Sanders emphasizes that iSTEM education is inherently problem-based. The STEM notebook will hit all 5 of the top reasons for using science notebooks. It will still be a thinking tool, offer formative assessment to guide instruction, develop literacy skills, help teachers meet the needs of a variety of students, and encourage teacher collaboration. It will be a place to pose questions, make claims, provide evidence, and debate with others, and it will be a place for students to reflect and examine their reasoning. A middle school STEM notebook is going to need to move from class to class. It will need to be a tool to help purposefully connect learning from different classrooms. Some ideas within the book, Teaching Science with Interactive Notebooks, may help students and teachers make these connections. This 2010 book by teacher Kelly Marcarelli helps teachers set up and implement interactive notebooks with their students. The middle school STEM curriculum will center around overarching questions or problems. All learning will link back to that problem. Marcarelli suggests students place an AHA Connections page in their notebook in the beginning of each project or unit. This AHA page helps the students organize the connections they will make throughout their study. The trigger is the spark of interest that leads the students to their question or problem. This may be based on observations, readings, whatever. The trigger builds student buy-in and leads to the big problem. Students gather evidence to help solve the problem from a variety of sources. This can be experiments, readings in any content area, math problems, any daily work. Teachers will purposely plan to align these experiences to help students gather evidence that will ultimately help them solve the big problem. Students are asked to gather and compile key ideas in the center of the AHA page. This is where students will create their own meaning, organize and synthesize learning from their experiences. Marcarelli suggests that students compile the evidence into a formal AHA thesis. The thesis will help students organize their thoughts into claims based upon evidence. Students will share their AHA thesis with each other and learn the value of scientific argument and debate to defend their ideas. The AHA Connections page and thesis statements could be critical pieces to include in the iSTEM notebook. Marcarelli also suggests a particular way to organize the notebook. Within a spiral notebook, she suggests that the left side should be for student output and the right side for teacher input or facilitated learning. I think this will help students bridge ideas from one learning experience to another. And this type of structure will also help guide teachers' collaborative planning, making sure the projects are cohesive for students. While the STEM notebook could be used by an individual, our plan is that the notebook will be used by the STEM team of teachers. As we have discussed, this is a supplemental tool to enhance and guide curriculum design. The teachers in this STEM project will be designing curriculum that is STEM-based and problem-based. This notebook will be a tool to support that work. What about buy-in for this strategy? There is already buy-in for the STEM curriculum project in the use of a design process notebook with the pilot school. The work we're doing with this pilot will spread to all Virginia Beach middle schools within the next 5 years. Science notebooks are entrenched in Virginia Beach coursework. Including the key elements of science notebooking in the STEM notebook will show that we're building on prior successes. For national buy-in, I looked at the new science framework. I think this framework will do much to promote iSTEM teaching. As we have discussed in class, engineering and technology have been identified as a fourth domain within this framework. With this in mind, I could easily see STEM notebooks embraced by teachers nationwide. There are still some concerns that need to be worked out with the Virginia Beach STEM team. Top of the list is how to assess this notebook, or even, do you assess the notebook? And we want to be sure we don't fall into the trap of creating a workbook. As student work matures, the notebook needs to be more student-driven. If we can begin iSTEM learning in elementary school, foster it through middle school, and deepen it in high school, just imagine the STEM literate citizens of tomorrow. Imagine this second grader as an adult if their passion for STEM is kept alive. What is an engineer? An engineer is a person who uses the design process to create and solve problems. They also use technology, and they use their prior knowledge, so they say thinking answers instead of junk answers. They cooperate so they can decide which plan is better, because it's better than one brain, because everybody's thinking counts. Thank you for joining me for this iSTEM Strategies presentation.